Hello everybody, I'm Benjamin. I'm happy to be invited to FluentCon North America 2021. Today I'm going to share a session about FluentBit Operator and our plan to evolve it to a more powerful Fluent Operator. I'm a senior architect of KubeSphere, and I'm also a member of Fluent and OpenFunction. Here is the agenda. We are going to talk about why we created FluentBit Operator in the first place, and a brief introduction, use cases, analysis, and most importantly, our plan to evolve current FluentBit Operator to Fluent Operator. And we'll explain the roadmap, a few demo, and finally some community stuff. So let's begin. Why we create FluentBit Operator in the first place? For a logging agent, it's important to be lightweighted and have lower resource footprint. And FluentBit is just a perfect selection for the logging agent. So we choose to use FluentBit. And then there are need to control FluentBit and its configuration through Kubernetes API because we are developing on the cloud native platform. So someone might ask why you create another operator when there are already existing ones. So our opinion is FluentBit itself is able to send logs directly to the final destinations. So FluentD shouldn't be mandatory, should be optional. So imagine if you have hundreds of nodes and all the nodes will send logs to the FluentD first, and then FluentD forward the log to the final destination. The FluentD might become the single point of failure, right? So it's more efficient and more straightforward if the FluentBit agent can send logs directly to the final sinks. So that's the reason we created the FluentBit operator in the first place. And then we have some issues. FluentBit doesn't have a dynamic config reloading interface, which means whenever FluentBit config changes, the FluentBit pod has to be restarted for the FluentBit to pick up the new configurations. It's not convenient in some cases, right? There are already some issues and discussions in the links below. So we have to solve that first. And here is the how a FluentBit operator looks like now. You can see that we have 6 CRDs, and the first CRD, FluentBit, is used to define the entire FluentBit daemon set, and the rest of the CRDs is used to define the FluentBit configurations. And you can, as you can see, the FluentBit pod will send logs directly to the final sinks like ES, Kafka, Loki, etc. So let's take a look at the details of the CRDs. We have input, filter, and output CRDs to define corresponding FluentBit plugins configurations. And the FluentBit config CRD is used to select which plugins to use by a label selector in the right one. So as soon as the configuration, the plugins are selected, it will generate the FluentBit config into a secret, and the secret will be mounted into each FluentBit pod. And the FluentBit CRD is used to define the entire FluentBit daemon site. It's a position DB and which configuration to use, right? And the operator will watch for all the CRDs whenever each of these CRD changes. It will reconcile and generate a new FluentBit configurations. So this is the CRD. And one important thing, one important issue we have to solve is we have to solve the dynamic config reloading problem of FluentBit, right? So the method we choose is in the FluentBit pod, we start a FluentBit watcher. We create a FluentBit watcher component, and the FluentBit watcher will watch for the configuration files in the pod. And whenever the configuration file is created or changed, the FluentBit watcher will restart the FluentBit process, and then the FluentBit process will be able to pick up the latest configurations. So in this way, we solve the dynamic config reloading problem. Yeah. So here, below is the link. If you want to take a look at how it's implemented, you can take a look at the code. And here is the Docker file. You can see here we compile the FluentBit watcher into a binary and use the official FluentBit image as the base image, and copy the latest configuration and the latest binary of FluentBit watcher into this base image, and replace the original FluentBit entry point with the FluentBit watcher. So in this way, the FluentBit pod actually started with a FluentBit watcher, and the FluentBit watcher will start the FluentBit. So this way, we solve the dynamic config reloading problem of FluentBit, right? And a user can customize the log processing phases by choosing different plugins for different phases. For example, for the output phase, if you have ES, Kafka, and forward plugin, you can just enable the ES plugin by setting the label enable to true and disable other plugins. This way, you can keep the configuration for Kafka and forward without deleting them, and you can enable them again whenever you need it, right? So it's very flexible, and the same applies to input and filter plugin. So this is how the logging processing can be customized. Then we can take a look at some user cases. KubeSphere itself is a good use case for FluentBit Operator. It chooses FluentBit for the logging agent, and we have needs to control the log settings from the web console. So the API server has to call some Kubernetes API to manipulate the FluentBit and FluentBit configuration. So this is one reason we create a FluentBit operator. It has CRDs, right? It can be controlled by the API server easily. We will have a demo later. So for to collect Kubernetes logs, you have to set up a FluentBit CRD first. And the CRD defines everything about the FluentBit daemon site, including the position DB. You can set a host path for it. the request limit and the configuration, toleration, affinity, etc. And then you have to define which plugin to use in FluentBit config CRD, right? So this is done by config the input filter and output selector, right? So you can select different plugins for your needs. And to collect the container logs, you have to define the input CRD. So specify where you can find the container logs, buffer limit if there are huge log volumes. And most importantly, you have to define filter CRD, right? The filter CRD will add some Kubernetes metadata to the log messages. And another important thing is to actually the metadata contains some useless field, so you can remove the useless field like pod ID or container hash to save your disk space, right? So and then you can define the output CRD such as ES, such as Kafka and Fluentd to send the logs to these things, right? And this is how the final log message looks like. You can see here the metadata. There are no pod ID or container hash, right? They are all filtered out. So this is how we create Kubernetes container logs. And we have needs, usually we have needs to not only collect container logs, but also we have to collect the kubelet logs on the node. So how this can be done through FluentBit Operator. The first thing is, kubelet is actually a systemd service. So we can use FluentBit systemd plugin to collect the specify a filter to collect the kubelet logs, right? And most importantly, you have to define a filter. What this filter does is, we have a requirement to query both container logs and kubelet logs in one single logging console, which means the log message has to be in the same format, right? So we use this Lua script to convert the kubelet logs to the same format as the container logs. And this is how the Lua script looks like. It's the most important part is here. It adds a Kubernetes metadata. It will use the host name as the pod name and use kubelet as the container name. And it is put into the kubesystem namespace. And finally, there will be a timestamp will be added. So in this way, we can query the kubelet logs together with container logs in one single console, right? And the same is for the auditd logs. You have users' requirements to monitoring what happened on one node. So the auditd can will put the audit information of one node in the audit logs. So we can specify the auditd log path. And similarly, we have to define a filter using the Lua script to convert the auditd log into the same format as the container log, like this, right? Yeah, this is the script similar to the previous one. We put the node name to the pod name metadata, and the container name is set to auditd. And it also put the namespace to the Kubernetes system. So this is how auditd and kubelet logs are collected. Actually, we have a requirement to do log alerting. There are several ways to do log alerting. One looks like this. The logs is sent to Kafka, and you can use some kind of Kafka consumers to analyze the logs from Kafka in real time and to filter out the logs you are interested and sending it to some notification channel. But this method is kind of heavy, right? You have to use a Kafka, set up a Kafka cluster and set up a few consumers. So a more lightweighted way is to process the log from the agent side, right? So we can also use a filter. In the filtering graph, in the graph field, we can add the log pattern you are interested. Whenever the log message matches pattern, it will be sent up to a webhook like this, right? In this way, we can do log alerting on the agent side. It's more efficient and lightweighted, right? So this is the use cases part. And FluentBit, as we have already know, it's lightweighted, it's high performance and zero dependency, and no single point of failure, right? But it also has some disadvantages. As we know, it has much less plugins than Fluentd, right? It has less powerful filter and parsers than the Fluentd. So in some cases, the Fluentd is still needed. So we decided to add Fluentd to existing FluentBit Operator and rename it to Fluent Operator. So currently, the FluentBit Operator looks like this. We have already discussed, and we are planning to add 3 more cluster CRDs here. Why we add this cluster CRD? Because FluentBit is actually a daemon set, and it collecting class-wide logs. So it makes sense to add cluster CRDs to collect cluster-wide logs, right? And most importantly, we plan to add Fluentd support, as Fluentd will be act as an optional destination of FluentBit output. It's optional. It's important. It's not mandatory. So the FluentBit still can send logs from itself directly to the final sinks, and Fluentd is one of these sinks, and Fluentd can do more log aggregation and more powerful filtering and parsing, and then send the logs to the final sinks. The Fluentd CRDs contains basically 5 CRDs. The Fluentd CRD itself defines how the Fluentd deployment looks like, and the Fluentd config and Fluentd class config contains information about input and filter plugins, and the output and the cluster output plugin defines where to send the logs. So this is with Fluentd and FluentBit CRDs are all added. We will rename the product to Fluent Operator. So it's more powerful and flexible than current operator, right? So this is the roadmap. almost 3 years ago, we created the Fluent Bit Operator, and we created about 8 releases till August this year. And to August, actually more and more contributors and maintainers are participating in this project from all over the world, including the US, Australia, Europe, and of course China. So after communicating with Fluent community, we decided, we agreed to transfer this project to the Fluent org. So this has happened in August this year. And the 0.9 release is the first release after we transferred the project to the Fluent organization. And the 0.12 is the latest release. We are planning to release the we are planning to add the Fluentd support and rename the product to Fluent Operator in Q4 this year. So if you are interested in the development, you can I will share a link to the proposal. You are welcome to participate in the development of Fluent Operator, right? And here is a few demos here. You know, this is the container management platform. We can see the log collection configuration here. We have already the ES and the Kafka output plugin configured. The ES is actually receiving logs, and the Kafka is closed. You can change the status here to be active if you want to send logs to Kafka. And here, if you edit the YAML, you will see this is disabled here, right? And below is the Kafka configurations. And for the ES, it's actually it's enabled, right? Of course, you can turn it off. You can add more things. You can add Fluentd. So next I will show a demo how to query the kubelet logs. You know, as we have mentioned before, the kubelet logs is put under the kube system namespace, and the pod we use the pod field to store the node name actually. So if you search master, you can find there are some logs for the kubelet, right? This is the logs for the kubelet. But if you have want to see the latest 10 minutes log, you can find nothing, because currently the kubelet input has been disabled. So we have to enable it first, right? Here we set it to true, and below you can find this is the kubelet logs, right? You can save it. We are taking effect. And you will wait a few seconds. The kubelet logs will show up. It will take a few seconds. You can see that the kubelet logs are scrolling down, right? So this is the demo of how do we collect and how do we enable the logs and the plugins. So this is done for the demo, right? And so if you are interested in participating in this project, you can find the GitHub and Slack information here. And here is the proposal for the Fluent Operator, right? And finally, I want to thank all the maintainers and contributors, especially maintainers from the DigitalOcean. They are very passionate and professional. So thanks, thanks guys. And that's all my session. That's all for my session. So any questions? I will be here to answer any questions. Yeah.